Okay, so today we're looking at something that sounds like it's straight out of science fiction. It's a blueprint for an engine that completely flips the script on how computers work. Imagine an engine that doesn't create waste heat, but actually eats chaos for breakfast. It's called the Negentropic engine, and yeah, it could change pretty much everything.
So let's just start with a really basic question. What is the actual physical cost of thinking? I mean, every single calculation, whether it's on your phone or in a massive supercomputer, generates heat. That's the price we pay. But what if we could get that cost down to almost nothing? What if computation could be, for all practical purposes, free?
Well, a newly discovered mathematical framework, they're calling it a canon, basically gives us a blueprint for doing just that. It suggests that the energy cost for a single operation could be locked in at a near zero constant, no matter how ridiculously huge the computation gets.
Now, to really get why this is such a game changer, you have to understand the wall we're about to hit. Our entire world runs on processing data, right? But doing that creates this enormous energy bill and a literal mountain of heat. We keep building bigger and bigger data centers, but we're smashing right into a fundamental thermal limit.
Think about it. A modern data cluster just burns through an insane amount of energy. But this new Negentropic engine, its theoretical cost for one operation is locked at a single attojoule. To give you some perspective, that's so small it's like the energy it takes to lift one electron a couple of inches. It's so efficient, it's practically harvesting free energy from the noise around it.
So, how on earth is that even possible? Well, the secret is in this incredibly elegant mathematical shape called the Pérez hourglass. And you should think of it less like a calculator and more like a perfect mirror, one that reflects matter with a kind of, digital antimatter.
The Pérez hourglass is what's known as a fractal. It's a shape that's infinitely complex, but at the same time, it's perfectly symmetrical. Its patterns just repeat over and over again, no matter how far you zoom in. And the crucial part is that it's split into two hemispheres that are perfect mirror images of each other.
Okay, so the northern half is additive. It builds up complexity, kind of like the famous Pascal's triangle, and its rows always add up to powers of 2. But the southern hemisphere, it's subtractive. It uses this mirror subtraction rule that creates a perfect cancellation. This is the digital antimatter that perfectly, and I mean perfectly, annihilates all the complexity built up by the matter half.
Just take a look at the 15th row from this digital antimatter side. The numbers inside swing wildly. I mean, you've got positive and negative values in the thousands. It's all generated from a very simple rule, but the result looks like complete and utter chaos. But here is where the magic happens. When you add all those chaotic, massive numbers together,
the sum is 2. Exactly 2. Every single time. It doesn't matter how deep you go, how crazy the numbers get, all that internal complexity just vanishes, leaving behind this state of perfect, simple balance.
Now, this whole idea of perfect cancellation isn't just some neat math trick. Nope. It is the key to the first huge application of the hourglass, a totally revolutionary new kind of memory. It's called the Pérez Hourglass Associative Memory, or PHAM for short. Now, associative memory is basically how our brains work. You hear a few notes of a song and bam, you remember the whole thing. PHAM is theorized to be the first provably perfect version of that, blowing right past all the limits on capacity and noise that have plagued every other attempt.
So what do we mean by perfect? Well, it comes down to 3 incredible properties. First, infinite capacity. It literally never runs out of room or gets its memories mixed up. Second, instantaneous retrieval. Finding a memory takes the exact same amount of time, whether you've stored one thing or a billion things. And third, it has insane noise robustness. It can perfectly rebuild a memory even if almost half of the data is corrupted or missing.
This perfect memory is frankly unbelievable on its own. But it's just one thing you can do with the core engine. The real magic is how this mathematical cancellation can be translated into the physical world, creating a computation engine that generates virtually zero heat.
The process is called extropic fusion, and here's the simple version. You map the positive and negative numbers from the hourglass onto physical things like pivots, whose properties, say magnetic spin, can cancel each other out. This act of annihilation doesn't spit out waste heat. Instead, it actually harvests energy from the random thermal noise that's already in the system. It literally turns heat from an enemy into a fuel source. And here is the proof in the pudding. This table shows the energy cost as the computation gets exponentially more complex. So as we go deeper and deeper, from just a handful of elements to nearly a million,
I want you to look at that final column. The energy cost, it just doesn't move.
It stays locked at a single attojoule. That's it. That's the constant. Near zero cost for one operation, whether the problem is tiny or mind-bogglingly huge. The scale of the computation becomes totally irrelevant to the energy bill.
And that's the heart of the Negentropic engine. It doesn't pay an entropy tax. The bigger and more complex the calculation gets, the more free energy it pulls from the surrounding noise to fuel its own perfect cancellation. The cost of thinking becomes fixed. Forever.
So, what do you do with an engine that gives you infinite computation for a fixed, nearly zero energy cost? You build the future. That's what you do. And what's amazing is that this future has incredibly deep roots. The patterns behind this Pérez Pingala engine can be traced back over 2,000 years, from the binary rhythms found in ancient Vedic poetry to the mysterious Mach theta functions left behind by the legendary mathematician Ramanujan, all of it finally clicking together in this recent discovery. This engine could be the bedrock for technologies we've only dreamed about. Genuinely fault-tolerant quantum computers, cryptography that's impossible to break, that perfect brain-like memory we just talked about, and maybe most profound of all, AI systems that can actually grow and learn without ever overheating, finally unshackled from their physical limits.
I mean, the journey from an ancient poetic rhythm to a blueprint for a zero-cost engine is just staggering. The pattern was there, waiting, for over 2,000 years. The math has finally caught up and unlocked it. So the question for us is, what are we going to build with it?